Hey, good evening. As you can see by the time, um, it's gonna be a very short video. Probably only one LeetCode. Uh, I have some explaining to do. Um, Yesterday I messed up really badly, and when I got back from classes, I fell asleep for like 4 hours. So like from 5 to 9, I slept, and I was up until like 9 a.m. yesterday. I mean, I like tried to go to bed at like 3. No. I was just tossing and turning, getting up, going on my computer for a little bit, getting off, trying to go to bed again, ate melatonin, nothing. Um, so I slept from 9 to about 2, 3-ish. Um, then I got up. I had to talk with my manager for my student job. Um, then what did I did something else, and then I think I took the trash out, and then I need to pick up new mouse, which for some reason honestly feels a little fidgety. Like I feel like it kind of skips on screen, which I'm not too happy about, but we'll see. But new mouse because my other one was double clicking. And then I went to Home Depot and I bought new light bulbs. Um, this one in my actual lamp that I just turned off, I want to get. I think I think I'm gonna return the bulb I got for this one and go get one that's a little dimmer because I want like a really dim light that I can like just have on my desk, and then on my big lamp that I have next to me, it's perfect. Like the light that I got for that one is perfect. So just want to fix this one. Perfect lighting. Then I got back and I haven't done any schoolwork yet, just because I was focusing on applying to stuff and student job and whatever. It's this is the first full week of school, and so I was like, I need to like I had no idea what was like due like at all. Um, I had no idea. I knew I didn't like miss anything yet, but I didn't know like what this week looked like in terms of what to do, and if there was something that was due maybe at the end of this week that's like a big thing or something like that. So usually every semester I make you can see it in the background right now, but I make an assignment tracker, um, and actually I was thinking I might revive the application that I was working on for a few years and like just got tossed back and forth. Um, um, and I might try to finish it um, and replace my assignment tracker with it because it'd be nice to put links to stuff. But anyways, what I'm gonna do is once I'm done talking here, we're gonna go through all the assignments I have, um, and kind of I have some stuff I want to talk about on what I want to accomplish this semester, um, and some stuff I'm kind of worried about. Um, so stuff I need to kind of like focus on, so I'm not so worried about. Um, and yeah, got my NSF account back. Um, so I'm going to apply to REUs. Won't lie, most of the REUs look pretty bad. But I'm still going to apply to them. Um, um, yeah. Anything else I wanted to talk about? Tomorrow I have, my linear algebra class changed from having an in-class quiz every week to just an online quiz, which is really nice. Um, but yeah, I'm realizing I really want to change this off of pink real quick. Um, oh no, it's on red. It's just I have like a dark mode. How's that look? Not the worst. Um, wow, these all suck. White is what you go for. Okay, let's go back to I already have that. Not to red, but to like, What, can I do a custom one? We're gonna crash, aren't we? Oh, fuck off. What was the one that I had beforehand that was actually looking like decent? Wasn't this? Oh, it was green. It was green. Yeah, I'll go with this. And then this one, I wanted to see if I could go to like a lighter blue. Okay, nice. Okay. Anyways, um, so yeah. Um, Tomorrow I have my 9 a.m., which, you know, we'll see if I can get to sleep tonight. That's gonna suck, that 9 a.m., which is my computer architecture, which not worried about, but every single class, starting with this one, I think this one is an appendix A. I don't really know what that is, but it's every single class. Um, I have um, oh, every class. I kind of want to move this. Whatever. Um, what was I gonna say? Every class, I have to ask two questions about the topic of like the week. So like I'll read up on what we're like studying that week, and then I have to ask two questions. Everyone in the class has to ask two questions. Um, so it's a little worrying because it's like, I mean, you come prepared, right? But it's like, I guess the thing I worry about is like, what if like my question gets asked, both of them or something like that, and then I have nothing to, I can't think of anything else. What happens then? I don't know. But yeah, let's go through this. I'll put my cam over here for now, and then I'll move it over afterwards. Sound good? Actually, would it make more sense just have the cam down here, like kind of permanently? Where did I used to have it? I used to have it like up here, right? And I moved it down to here. Or just doing a four corners, I guess. See, the only thing is I like to dine. Oh, whatever. Usually the heavy stuff is towards the left, I'm pretty sure. So we'll just do this for now. Okay. So Math 235 is my linear algebra class. The whole gist is I just have a homework and a quiz. Between 4 and 6 of those due every single week. So, and that's the earliest one that I have to have done tomorrow. Um, and then comp sci 311 is algorithms. One second. Oh, sorry about that. 311 is algorithms. This is a weekly homework with challenge problems like every other week and 3 or 4 exams. Comp sci 230 is a worksheet and a quiz just about every week. With like projects here and there. And this also has 3 or 2 exams. And this class is pretty. One second. I'm just hearing weird stuff. 230 is my low level class. So systems overview, data representation, machine organization, an assembly interpreter. That'll be cool. Assembly interpreter, memory hierarchy, um, cache simulator, virtual memory, um, processes, pipeline, parallel processing, synchronization, threading, networking, and then networking, threads, single pipe processes, and also there's a section on like the Rust programming language at the end, which is pretty cool. And then finally, my 535, which is um, this is the class that is going to be kind of crazy because it's computer architecture, which is notoriously a hard class. The only thing that's amazing about it is no exams, but we have a really big project, which is designing. I mean, you can see we have like a proposal, and then we have to present our proposal. Okay. And then once we do all that, we do our final proposal, and he'll approve of it. Um, we have a demo of memory and cache timing, which is like a mid-semester project, a simulation that we have to do for the project that will is due, and then we. So this is the thing: is the whole project is a full um, UI that has an instruction set architecture for it, like a chip, and does basic functionality like integer and matrix, calculations. Um, in this UI, will have it so that you can like select a chunk of memory and you can do some sort of operation in the assembler, and there's actually a disassembler that you can make that can also like kind of show you exactly what's happening based on memory, and kind of like register stuff you're doing with the registers. Anyways, this is something that we're going to be working on this week is the architecture. Um, I want to do this just throughout the week, but by next Monday, I want it to be have a rough draft of that. Um, but I just want to learn a lot more because right now, um, like the class I took last semester, 335, how computers work, a lot of the topics were very fuzzy for me. Like we coded in assembly, and I understand a lot of like the operations, and but like it's like I like just the simple things are just eluding me, like a control, like an ALU or a control unit, or you know more details about like how a cache works, some memory stuff, um maybe some branching stuff. Just a lot of things that I want to review on here. So yeah, so how the rest of this week is really going to look is making sure I get one LeetCode done a day, working on homework, and kind of like studying up mostly computer architecture, um, and then working on a project if I like have time or we get ahead or something like that. But that is the plan. So we'll do the LeetCode right now, um, and then I want to actually do LeetCode, not LeetCode. And then yeah, we will. Why is this like? I think I have to go to problems, then it'll show up. Bum, bum, bum. We finished array and string, and now we're on to 2 pointers. 2 pointers. Do not return anything. Modify nums in place. Given an integer array run, nums move all zeros to the end of it while maintaining the relative order. 2 zeros, just move it to the end. Um, I'm trying to think because this is called two pointers. Well, I could do, but time complexity probably isn't that pretty. But I could do for index in range of nums. If nums at index is equal to 0, then nums at index sorry, this is going to be like a while index is less than the length of nums minus 1. Because if we're doing deletion, what I want to do is I want to say if this is equal to 0, then nums at del um, I want to delete it and not do that. And then I wanted to do, I wanted to do nums dot insert at the length of nums minus 1. Insert a 0. Or wait, I can just append, right? No, I can't append. No, I can't append. I can just do a nums dot append 0. Right? And this is going to be index plus equals 1. And if we're deleting, then we want to do an index. I can just do a break, actually. I think that's easier. Expected. I think it's because of this break. Let's just do an index minus equals 1. Why would this be? Okay, so we say while index if nums at 0 is equal to 0, delete that. Oh, wait, just do else. What am I saying? Just do else. Wow. Oh, when I get to the end, it's that is true. So I need to do a moves, right? And so moves will be incremented every single time. So moves plus equals 1, no matter what. And so we want to break when moves is equal to the length of nums minus 1, right? So like here, I'm going to have 0. I'm going to have 0, and I'm going to delete it, append it, and then move is going to be 1. Okay, and we're going to be at 1. So now it moves us at 2. Then we go here. Moves us at 3. Moves us at 4. So the length is 5, then at 4. So this should work. Oh my god. Yeah. Just because it kept getting to the... Once we modified it, there was just zeros at the end, so we were just hitting this case infinitely, pretty much, and just deleting that index and appending an index, so it was just forever running. This is obviously an O of n, but this can be done more efficiently, I think. It probably has something to do with like oh my god. It probably has something to do with like um oh, I don't know. This isn't the 2-pointer thing, but I'm trying to think like if I had 2 pointers say next to each other. Let's look at it like because usually it's like if you start on a pointer here and a pointer here, right? It's like okay, this pointer's at 0, this pointer's at 12. Let's swap them. But it's like I don't want to swap them because then that messes up the order. I guess the 2-pointer thing could be like if either of the pointers are 0, or sorry, if the first pointer is at 0, swap. So we swap. And then we move. The first pointer is at 0, swap. So then you swap. But then we could leave that behind, right? Because if when we get to the point of there being a 0, 0, I mean you could do 2 passes technically, right? If you did 2 passes, yeah, that's just the weird thing is that it's like, yeah, you could swap if the 0 is at the first pointer, right? But then when you move it and it's at 0, 0, I mean, you could have the condition when it's at 0, 0, and then you just say, okay, right here, you swap, and then you move forward, and you say 0, 0. Is this 0, 0? Yep. So you swap, and then you go here. Is this 0, 0? Yep. And then you just leave. But what if I said, okay, if both are equal to 0, 0, right? Then swap the first digit with, if both are equal to 0, 0, then move the right pointer forward again and swap. Let's just see. Let's just see if I can do something here. So left is 0, right is 1. What I'm thinking, okay, is we say while right is less than the length of nums. Okay. What we want to do is we want to say, okay, if nums at left equals 0. Wait. Yeah. If the left at nums is equal to 0, then temp is equal at right. So now we're going to say nums at left is equal to temp. Or no, I don't have to do this because I know it's going to be 0. Because we know what nums at left is right now. So we can just say nums at left is equal to nums at right. And nums at right is equal to 0. Okay? So this is if the left value is 0, then we do this, and then we say left plus equals 1 and right plus equals 1. Okay? We shift. So now in this example, what's going to happen is that we're at 0, 0. So I kind of want a case of saying if nums at left equals 0 and nums at right equals 0, then we want to do something. Oh, then I could literally just say nums at left is going to equal nums at right plus 1. Right? Nums at left is going to be equal to the next thing. How about while right plus 1? So if maybe this, we might have to change this. Then the left value is equal to that, and nums I don't know if this is going to work. Let's just see. Okay. So they get paired up here. They move here. Wait, what? Nums at left should be equal to nums at right plus 1. Like, this should be equal to this now. How's that possible? Print me left and right. Whoa. These are off by one. So if nums at left equals 0, what, and nums at right is not equal to 0? Is that what I have to do? Do you work? Okay. So let's do this, and let's say if this is equal to this, and right plus 1. How about that? Uh-oh. While right is less than the length of nums. So it's correct, and then it just never ends. It just keeps swapping this. Okay, what if I do... Would this be less than or equals to now? What? Right is 4. The length of nums is 1, 2, 3, 4, 5. Okay, what if I say if right... Oh, God. What? In what world? Oh, in this world. So it's getting to the point, right? So maybe I do it at the end. Well, no. Well, no. So what happens is if left is equal to this and right is equal to this, right? Maybe I do put it down here. Come on. You know what? I give up. We're just going back to the last one that worked. I want to see what the two-pointer solution is, though. Let's go. Left equals 0 for right, and if num's at right is not equal to 0. If, okay, so left is here, and right is also here. If num's at right is not equal to 0. So like, let's look at this case. So it is equal to 0. So we'll just go back and right will go to the next one. If it's not equal to 0, then num's at right equals num's at left. And num's at left equals num's at right. So it just swaps. Okay, sure. And then left moves forward 1. So now we're on the same one. Equals 0, so then we just go forward. So what's the principle here? The principle here is that if the right pointers ever equal to just any value, right? Then just swap them, right? But if it's equal to a 0, don't swap. I get that. It's not horrible. Let's submit this one last time. Oh, I never fully did this. My bad. Also, it'll be a lot cleaner to do this. Okay, that's cleaner. Okay, classic mode. And I think I have to end the video here because I still have to upload this in time. Amazing. You think I can? It's gonna be a buzzer beater if I try to do another one and then like fail. We'll see. I'll read it and see if I think I can get it done pretty fast. Given two strings, S and T, return true if S is a subsequence of T or false otherwise. Substitution of a string is a new string that is formed from the original string by deleting some of the characters without disturbing the relevant positions. Um, we did this at one point, I'm pretty sure. But it should just be 2 pointers. Um, and you go and you look for the first variable. And when you hit the first variable, right, then you start incrementing the second pointer. If the second pointer ever equals that first variable again, you set the first pointer equal to that again, and then you start setting out the second pointer. If you ever find the second character, then that pointer is equal to that second pointer, right? Um, and then you keep going. And I mean, at that point, it doesn't matter if you can find. Is it always 3 letters? Wait. Um, I remember what it is. It's like if you can find an A and then a B, let's say, and then you find, let's say, another B, another A, sorry. It doesn't matter because you already found an earlier A. And if you found another B, it wouldn't matter, right? Because if it's in sequence, if I find the first character, right? How is this even 2 pointer actually? How is this not just one continuous pointer? Just go through each index and say like is it not just a for each in or okay, for index in the range of uh get the wait for each of a string. Yeah, I mean I guess I could do okay. Here, just because we don't have a lot of time, I'll do S. It's T we want to find. So T array is a list of T. And we want to say index equals 0. And then we want to say for each in this, if each at index, sorry. If T at index is equal to each, then index plus equals 1. If at any point index is equivalent to why don't I just do array S, array T? For T index, if this value is equal to this value, okay, so if index is equal to the length of the array S, just the length, right? Or no, wait. If I have 0, 1, 2, so the length is 3, yeah. If this is ever true, return true. Otherwise, return false. In what world? For each, so we have A. If 0 if array S at here is equal to each. So if so A should be equal to A, right? So index is now at 1. Oh wait. Oh wait, no. And then it should be, we're on here. We're on B. Wait. I'm so confused. Print each. Why wouldn't this be working? A, B, and C. We found all. So why it has to be this condition isn't hitting. Index is equal to the length of this. So this would be print two, 3. Okay. So that should work now. Still weird, but okay. In what world? Okay, let's go back again. Wait, in what world? Oh. Don't. It's late. It's late. Don't. Just don't. Yeah, I did just change the print statement and not the actual code. You got me. Okay, you got me. List index out of range. What do you want? If S or why did I run it? Well, I guess syntax error. Whoa. Why did that fail? If S equals nothing or T equals nothing. Oh, it wants true. My bad. Output is true. Index would be 0. If index is equal to the length, if 0 is equal to 0, return true. Okay. How do I get around this? I could set this equal to... How do I get around this? I guess... I mean, the whole thing that we're checking here is that if we got to... We return true if we got through everything and they don't match. But in the case of it equaling 1, I mean, I guess it's just for this case, right? Oh my god. What can I say? Why is this not just so simple? Oh, because now I'm... Okay, yeah. Now I'll know where to hit this. Would this be true? What? Wait, how would this be true? For each an array at T, if index is equal, this return true. Okay. What? Before we return true, print out each, to be honest. What? If index is equal to -1, we set it to 0. This avoids the case of it just being 1 and 1. So now we're at 2. So let's print array S at index. Let's print index and let's print each. Oh my god. I need to end this video. So it's a B, we're at 0. It's a B. We increment index to 1. If the index is equal to the length of the array S minus 1. But this, why is this the length of the array minus 1? It should be when the index, in this case, is 2. I mean, what? So why is this wrong now? C 2C. So we're at 3. Is the length of the array not 3? Print the length of array S. Three C3. If the index is equal to this, return true. Oh, it's because I'm at the last value. Oh, wait, so what, do I just want to say that? Beats 100%. Okay. Yeah. Oh, wait. Yeah, beats 100%. Okay. Okay, I need to end this video because um I need to still upload this, so I don't get how this beats 100%, to be honest. another two-pointer approach. Where's the code, man? 0, 0 while. So stupid. Like turning both these into arrays just seems not needed. A double base case seems disgusting. Setting an index to -1 and then having to send it back to 0 if it's -1 because I'm, you know. Oh, wait. I don't think I need to do this anymore because I'm changing this to here. Because now it'll go through and we're saying index is 1, so. But now that will be right though? Yeah. Okay. That's a little better. The only other thing would be this would be a little cleaner. Right? I think this, I like this. Okay. Let's submit this and then I really need to end this so I can upload this before midnight. Okay. Beautiful. Look at how nice it's coming along. Okay. Okay. Um, not, got 2 LeetCodes done. Not a bad. Got 2 LeetCodes done. Um, did my assignment tracker. Um, pretty successful day. Just want to wake up earlier tomorrow. Because today I woke up really late because I napped by accident the day before. So, um, or I guess yesterday. So yeah. So I will see you tomorrow. We'll probably be working on linear algebra and looking over some computer architecture stuff. I'm actually going to. The only reason I'm not recording more right now is so I can upload this before. I really don't want to miss a day and lose out on a technicality of missing a day. So, but I'm going to look at computer architecture stuff tonight, to be prepared to like ask a question tomorrow if need be. And just I need to brush up on some stuff. So yeah. We're just gonna be working on classes and LeetCodes for the next few months probably. Um, yeah. So thank you for watching, and I will see you tomorrow. Bye.